Hello guys, welcome back. So today I rushed with this problem, so I probably am wrong, but okay, here we go. So today I decided to use these 8 constraints, A through H, and basically do the least possible shapes to cover all these constraints. It was hard. So anyway, I'm going to go over the constraints. Constraint A has a diameter of 10 centimeters. Constraint B has a side length of 10 centimeters. Constraint C has a vertical height of 12 centimeters. Constraint D has a volume of 48 centimeters. Constraint E has a slant height of 5 centimeters. Constraint F has a surface area of 360 centimeters square. Constraint G has a volume of 100 cubic centimeters. And constraint H has a slanted height of 13 centimeters. Now moving onward. The prompt is, you need to use each of the following characteristics to build as few three-dimensional shapes as possible so that each property is used at least once. How many 3D shapes do you need to do this? Be sure to describe how and why you built each shape the way you did, and be sure to identify which shape satisfies which constraints. So my initial guesses were 2 shapes, since there were 2 volume constraints, D and G, and I assumed that the rest would go along as well, but I was wrong. And then I've thought of 3 shapes, but surface area and volume couldn't go together, and the correct answer is 4 shapes. So shape number 1, I decided to do it as a slanted cone, and this constraints that the shape covers are A, E, and H. I chose to make this shape a slanted cone since I wouldn't have to worry about 2 shapes with different slant heights, and also it covers the circle shape. And that is it. Shape number 2, I decided to do it as a rectangular pyramid since I could cover area and length and vertical height all in one shape. So this shape covers constraints B, C, H, and G. I now chose to create my shape as a rectangular pyramid, of course, since I could cover 4 constraints with this. How did I know it? I knew it because I solved for volume. And according to the right triangle thing, I decided that 13 and 12 go together for a vertical height and slant height. Slant height is the hypotenuse. And also vertical height is used in the volume of a pyramid. And also I decided to use 10 centimeters as my base since it's also a constraint. Then I used the volume formula for a pyramid to make an equation using 100 cubic centimeter volume. In the equation, I put the 10 centimeter length and the 12 centimeter height, or aka the vertical height. So I got the width of 2.5. That's a typo. Just rushed through it. And now, so I algebraically solved it. Basically plugged the numbers in. So now this pyramid was a success. And the third shape is a constraint. It only covers constraint F. And I decided to create this shape as a rectangular prism since it's the easiest way to get constraint F and I wouldn't have to deal with fractions. Couldn't put constraint D since it did not go with the volume, so I had to do it separately. Finally, 5 out of 5. This shape is also a rectangular prism. It only covers constraint D. And I chose to create my shape as a rectangular prism since it is easier to create a volume. And I made 2 prisms for this problem since shape 4 and shape 3. Those are the two shapes. And surface area and volume couldn't work in my book. And overall, this problem was really, really difficult because I had so much trouble with 3D shapes. It was the nastiest question ever. And there's my name. So anyway, good night, guys. So tired.